All right, so today we're going to get into the combined gas law. So there's three gas laws, Boyle's law, Charles' law, and Gay-Lussac's law, that we can combine into one equation. And it relates pressure, volume, and temperature to one another. So here is the formula. It's pressure P1 V1 over T1 equals P2 V2 over T2. And so P stands for pressure, V is volume, T is temperature. And then the ones are the initial and the twos are the final. So what is it before and after we change or make some sort of change to our system? So a couple things. First of all, we need to make sure our pressures have to be in the same units. So they both have to be in atmospheres, they both have to be in millimeters of mercury, both have to be in kPa, whatever. Make sure that they're the same. Temperatures have to be in Kelvin. Make sure that your temperatures are in Kelvin. If not, then you're going to get the wrong numbers. And then our volumes, most of the time they're going to be in liters, although they could be in other things as well, like milliliters. But most of the time we're going to use liters. Okay? So let's go through a couple of problems. What's going to happen basically is you're going to do a proportion where you're going to cross multiply and divide. That's going to be the easiest way to do this. So here is number one from the assignment. So if the pressure of a 7.2 liter sample of gas changes from 735 torr to 800 torr, and the temperature remains constant, what is the new volume of the gas? Okay, so what are we doing? We're changing the pressure from 735 to 800, and we want to know what happened to the volume. Now, the other thing that's key here is the temperature remains constant. So in our equation, P1 V1 over T1 equals P2 V2 over T2. If it says something remains constant, we can actually ignore that. Okay, so since temperature is constant, our equation then is P1 over V1, or P1 times V1 equals P2 times V2. Okay, so now what's my P1? Well, what did my pressure start at? 735 torr. So that's going to be 735. That's P1. And my volume is 7.2 liters. That's my volume. That's volume 1. Then I changed the pressure to 800. So now my new pressure is 800. And what is the new volume? So I'm looking for V2. Okay. So now I'm going to do my math. Okay. So I'm going to do 735 times 7.2. That equals 5,292. So on this side, it's 5,292 equals 800 times V2. Now to solve for V2, I would divide both sides by 800. So then I divide by 800. I get 6.6. Let's round that to 6. So V2, these cancel. V2 equals 6.6 liters. And that's my answer. Okay. And I did put the answers here, so you should get whatever I have there. All right, let's try another one. Number 2 here. A gas whose pressure is 1.34 atmospheres occupies, so 1.34 atmospheres, that's my pressure, occupies a volume of 46.9 liters. The gas is allowed to expand to 65 liters, and the temperature remains constant. What is the pressure of the gas? So what is the pressure at the expanded volume? So I'm looking for pressure. It says temperature remains constant, so I can ignore that. So it becomes P1 V1 equals P2 V2. So my pressure 1 would be the 1.34 atmospheres, and that occupies a volume at 46.9 liters. So that's my V1 equals P2, that's what I'm looking for, times 65 liters. So if you think about it, right, I went from a smaller volume to a bigger volume. So the volume increased. So what should pressure do? If I put the same amount of gas in a bigger space, the pressure should go down. So I should see a decrease in pressure here. So I have 1.34 times 46.9. It's going to give me 62.85 equals P2 times 65. I divide both sides by 65. Those cancel. P2 equals divided by 65, 0.97 atmospheres. So, did my pressure go down as I expected? It started at 1.34, now it's 0.97, so yes, it went down. And again, that's because we put the same amount of gas in a larger space, so therefore pressure should go down. Okay, so that's how you do these problems. I hope this helps. Let me know if you have any questions.